Hi, everyone. Welcome to the breakout. I'm going to be speaking on Temporal and trying to keep time on our side. Everyone in this room, I am willing to bet, has asked the question, come on, Brandon, why did you make date in JavaScript so bad? Who here hasn't had that experience? See, just what I said. The reason is, as always, time. Brendan had 10 days to get JavaScript done, and he just picked Java util date and basically copied that straight off. Java util date wasn't a great thing to begin with, so that didn't make it any better. There are lots of problems with JavaScript dates. There's no time zone support except for your local time, whatever that means. It means wherever your system thinks it is in the world, though it may not be. And UTC. Parsing dates from strings is just unreliable and different across browsers and just a mess. Date objects are mutable, so when you get one, you just have to pray that nobody touches it. Daylight saving time is actually who knows which one you get, especially when there are the same time existing twice around a daylight savings time transition. Making calculations with dates, so what is next month, is strange and unwieldy. And don't even try going for a Hebrew calendar or a Chinese calendar or with Ethiopian time or any of the other time systems and calendar systems around. No way. And it's also nigh impossible to get right. There are so many little niggling bugs that you will find in your date code. For that, I refer to you to YouTube talks by Maggie Pint. She will explain all the pitfalls of all the things you can do wrong, and watch that because you will be going back to your code saying, oh my God, I just have to fix this. This will break me soon. Thing is, that's an example I just mentioned. Get the next month. So let's go naive, right? We get a timestamp, milliseconds since epoch, set the month to 1 month in the future. Really? I have to get it and then set it to +1? What happens in December? Well, thankfully, date works for that, sort of. And then I return the new timestamp. Yeah, that's going to really break. In London, it works. In New York, that works. In Vancouver, that works. I've now tested my code. This is all brilliant, right? It works. It's good code. I have all my tests. They all work, except I actually moved to Sydney. Crap, what happened there? And it's actually not even just the daylight savings time difference. It's actually 3 days difference. Yikes, it doesn't work. And that's some of the problems with date. Date is hard. VentureBeat had an article out just last week that I came across where it says, Apple daylight savings bug strikes yet again, looping Series 4 watches. This is VentureBeat, right? I'm quoting here. Given that Apple has been making dedicated watches for over 3 years and computers with clocks for decades, there is no excuse for recurring daylight savings time bugs in its products. Well, actually there is, because we know time is really, really hard. Dates and times are a killer. Even Snapple acknowledges that in their real fact number 341, of the 92 counties in Indiana, only 5 observe daylight saving time. So even within a single state in the US, that doesn't mean anything, right? And most of the issues, so we are going to fix this, right? So I'm introducing the protagonists in this story, / my co-conspirators. There's Andrew Paprocki, a colleague of mine at Bloomberg. Brian Turlson, the initial inspirer of my interest. Then there's Brian Turlson, the colossal communicator of chronology. I've already mentioned Maggie Pint, the titan of things temporal. There's her fiance, Matt Johnson's distinct distiller of direction. The studious scribe of specifications is right over there. And then there's me, the parliament producer of polyfills, because I'm just not much more practical. And we will be bringing the new show to you straight on TC39, Breaking Time. It's actually quite apropos because my lab happens to be not under a laundry, but on GitHub. So, if I get raided, not a big deal. And the nickname for this guy, Heisenberg, is also brilliant because we're talking TC39. So you can either know what you're talking about, what a specification is about, or where it's going, but not both at the same time. So all of what I'm going to say is the state of the world as it is right now. This might change at any moment. So have a look at the actual spec. We called it temporal because temporal means relating to time. It also means relating to worldly affairs. And that's the bit that is important to me because I want this to be a real-world, usable, well-done API that actually fixes the things that we suffer from on this earth and not in the future. Here are some of the design goals we have for Temporal. We've realized since, for the last couple of years, that immutable objects are actually a really good thing, that they make life a lot easier. So in this API, we want all objects to be immutable. We've also ran across the fact that actually milliseconds aren't all that useful all the time. System timers work in microseconds, and who knows what they will work in the future. So we said, actually, we want nanosecond precision. It doesn't matter that we can't get that at this time from operating systems. That's a precision we want to work at. This way, we have a chance to do times right in the future as well. I want arbitrary time zone supports. I live in London. I deal with people in New York. I have family in Vienna. I am dealing with Maggie in Seattle. I desperately need time zones. And I guess many of you will as well. I also like to have arbitrary calendars. I mean, nothing against the proleptic Gregorian calendar that we most commonly use, with a 24-hour based midnight to midnight day. But there are other people and other cultures in this world, and I'd actually like to have a Hebrew calendar that works properly, and I'd like to have Ethiopian time where the day starts at 6 in the morning, our time, and make that possible, and integrate those cultures as well. Though that's not part of the temporal proposal itself, I want to make it possible to do that. I actually want computations to be a lot simpler than having to get the month, add one, and then push a random number back in. So simple computations API. We want strings to be predictable. We want to know what they will look like with a guarantee. And there's a great standard out there, ISO 8601. We want to handle ISO 8601 strings, and we want to do that properly. And we want to be explicit about what it is we're doing. I'm going to be speaking more to that. We want to be explicit and have a chance at getting the correct results. And this is the main difficulty with dates in programming right now. It's the mental model. We're thinking, let's just go for a date and, as in JavaScript, just add time, because if I don't have time, then if I just have a date, then I'll just zero out the time, right? And use the same thing. And that's a problem. That's the wrong mental model. And we need to create a set of objects that has the right mental model for the task. And that's where we get that from. We need an absolute timeline that has the characteristic of continuously progressing forward, never skipping a thing, never being continuous and increasing, right? We don't want to have to deal with dates in absolute time that happen twice. We don't want to have to skip strange steps that never happen, so that there's a 2:30 in the morning, that should always be 2:30 in the morning. And then there is local time, or specific time. It's what, when you look at your clock, you see 12:12 right now. And that 12:12 is a time, whether that's today or tomorrow, that's just a time, right? And for things like recurring events and calendars, daylight savings time doesn't make a difference to your calendar. Your meeting with your teammates will always be at 12 o'clock. And it'll be at 12 o'clock next week, and in 3 months down the road, it'll also be at 12 o'clock, whatever that happens to mean at the time. That shouldn't shift just because of a daylight savings time change. And it's also not attached to any point in absolute time, therefore. But fundamentally, we're talking about dates and times in combination. Today, 11th of October, 2018, according to the proleptic Gregorian calendar, at 12:13 by now. Couple of seconds, couple of milliseconds, couple of microseconds, couple of nanoseconds, couple of, yeah. The important thing about the distinctions between those two and why these objects, they don't have a connection to absolute time, but they do have a concept of calendar. They're based on something very specific, and if I exchange that to a Hebrew, it should still work, but detached from absolute time. We have civil date coming out, which is just a date. And how important is that, right? Your birthday doesn't start at midnight and end the next midnight in the time zone you happen to be in. It's that date. It's a day. If I put in my calendar, I'll be spending all day on the 11th of October at JS Interactive, right? And I enter that in London, it doesn't mean it goes from that I'll be spending midnight London to midnight London at JS Interactive. It means that day. So for that kind of thing, we need those correct abstractions. And again, this is local time, right? Just because I enter that day in London doesn't make it London time. It makes it wherever that thing happens to be. Same thing for time. I've mentioned it earlier with the recurring appointments, right? So these are concepts, and they're not attached to local time, and we need all three of them. So a single date just doesn't do it, right? But 12:15 doesn't give me enough. It doesn't attach to absolute time. It doesn't make computation any easier. Sometimes we do need to attach it to absolute time, right? Because if I say 12:15 is our meeting, right? And I send that to somebody in London, well, now they need to be able to say, actually, what does that mean for me in London, right? Doesn't help them that I say, yeah, it's 12:15. Actually, 12:15 is 8 o'clock at night, 8:15 at night. And they need to know that. So we have absolute time. We need it. Absolute time in temporal is reflected as an instant. It's just an instant in time. The important bit about the instance is that it has no concept of days or dates or times as we know them, as clock times, because it doesn't need to. It's just a continuing progression of time. It's a point in time. It also has no idea of time zone, because it's just a continuous point in time. That's great for logs and that kind of thing, right? Where this happened at a specific time on this planet. It doesn't matter where. It's still that same time. And it therefore has no concept of days or months. It can't do time maths. And it's good that it can't, because of our example of not working in Sydney, right? And then we have zoned datetime, which is the unholy matrimony of those two timelines. It's meant to represent a specific point in time in a specific time zone, and therefore have the dates and times and months and years of that time zone at that specific point in time. And it marries a civil date time, which is just anywhere, to a specific place and therefore a specific instance in time. It connects the two. So those are the 5 objects that we are currently proposing. And with that, we can actually start rewriting our next month function that I had up earlier, right? Let's type here. Function next month, right? And we have our timestamp again. And we get our instant because we can get that from our timestamp, right? And we have to get it from milliseconds because that's all we have, right? But we are now nanosecond accurate. And then we go, well, we have to attach it to a time zone now, right? Because we have to create a zone, because otherwise we have no dates or months or years or anything. So with zone, well, what zone? Where do I have that? And now we realize that our next month is actually time zone dependent, and I need that parameter. So our next month already changed because we now are working with the correct mental model. We know that you can't just add a month to an instant that has no connection to time zone. Well, and then I can just say the next month is actually just month plus 1. I want simple computation APIs, right? And then I can actually return next month the instant and just get the milliseconds back. Having the correct mental model leads to and an explicit way to express that allows us to actually then work forward. Now, I could also go ahead and say, you know, next month is really a local thing because I'm talking to my mate next door, right? I don't want to deal with a fixed instance. I just tell him next month. So I actually create the same thing with a civil date, right? I can do the same calculation. And there it becomes even easier because I just say civil date plus 1 month, and that's it, right? The difference is that civil date isn't attached to the absolute timeline. So that means no instant. And that also means no daylight savings time. So if I add an hour, it'll just be hour plus 1 rolling forward, because I don't know where that is or if there is even a daylight savings time transition. So depending on my use case, I can now explicitly use the thing that I want to worry about. If I'm worried about something in absolute time, then I can use zone datetime to work with absolute time. If I don't worry about time and I'm more abstract in a calendaring app or something like that, I use civil dates because that's what people talk in when they're communicating time locally. I think we've achieved, with our design right now, we've achieved the objectives that we've set out for ourselves, that all objects should be mutable, because none of these can be muted. You use operators like plus to add stuff that create a new immutable version of the result. We have nanosecond precision. We can actually do time zone translations. I set it with time zone to an instant, but I can have that same instance with different time zones, right? So therefore, we've now made it possible to support arbitrary time zones. If you implement another version of zone datetime that supports the Hebrew calendar, you can do arbitrary calendars and time modes. Not a problem. All you have to do is do it. We might go there in a future proposal. All of these objects produce proper ISO 8601 strings, and they can all properly parse from them. So String handling is a lot stricter. You can't just pass in a random formatted date anymore and hope that something sensible comes out. You have to pass in ISO 8601. But if you do that, then it always is guaranteed to work. And because we're more explicit, we now have a chance to be actually correct in our usage. And I think that's actually a huge step forward for dates and times in JavaScript. I think that we will make people's lives a lot better. But most of that is theoretical right now, because the real question is, when can I use this, right? I mean, it doesn't help me if we are thinking about a specification. Well, actually, you can use it today, because we have a polyfill that we published on NPM. So the QR code will take you to the NPM package as well. And you can play with it right now. This thing will change, so don't expect API stability until the proposal is done. But you can play with this right now, because if you go back to some of the talks by Jory earlier in the day, or the panel that Maggie was leading on TC39 and all that kind of thing, right? The most important feature of these proposals, and this is the actual point of this talk, is getting people involved and getting feedback and getting usage and getting people part of the discussion. So the real purpose of why I'm here is not to tell you about Temporal and how to fix dates and times. The real purpose of this talk is to get you involved. And you know what? I have the necessary qualifications, and so do you, right? You can just scan the QR link, go to the proposal GitHub page, right? Work in the issues, join in the discussion. They're very spirited, and they're always interesting. You can go on about dates and times for a long, 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 long time. Please join us. Let's try to make the next set of dates and times and temporal objects actually work and actually work properly for JavaScript. Wouldn't it be great if JavaScript was the only language on the planet that could actually do dates and times properly? Let's work on that. Let's make it happen. And if you just want to read the proposal as it stands right now, again, this is shifting ground. Remember Heisenberg? I can tell you where it is. I can't tell you where it's going, because that really depends a lot on you guys. That's it for me. Now, I'm happy to take any questions, and I'm betting that Sasha and Maggie, and who else do I see, come and join me. They're great at answering questions about dates and times if you have them. So what are your questions about date and time? Yeah. That's a brilliant question. The question was, the problem with pulling in libraries such as Moment.js is that they're huge, and especially when you're using Moment time zone, it becomes a huge download for every web page. And the question was, is part of the idea of this to make that go away, that huge download? And actually, yes, that is part of the reason. So Maggie is a maintainer at Moment, right? So the idea is to reduce the download time by putting it in the browser. Yes, that is part of it, especially when you're thinking Africa mobile phones. You don't want to pull down time zone information over a mobile line in Africa. You really do not. And you don't want to do it for every single web page you go to again and again and again. The other part, though, that sort of relates is the browsers actually already have all the time zone information, because there's the Intel namespace for date and time formatting, so you can already format dates and times in different time zones. So the browsers already have a form of time zone database with them. All the operating systems, whether it be on most phones or on most computers, already have some version of that with them. So it's not even bringing it along now as a browser. It's really let the browser use whatever the system already has. Great. Maggie, come on. Yes, please do, bike shed. Come up. I'm actually looking very much forward to those detailed conversations. So if you want to join us for lunch, then and have that conversation, I'm ready to go into the fine details of all of that with any of you. So yeah, more questions, please, please, please. I love them. They actually make this worthwhile. Yeah. I think mostly because a lot of the protagonists in this screenplay are either moment maintainers or heavy moment users or both. I think it influenced it insofar as they all know Moment intimately and know all the mistakes that were made in Moment and all the things in terms of API that could have been better and all the learnings out of that. So really, this is the grandchild of Moment, right? So Moment.js came about, tried to fix this problem, and they did a great job at it, right? As you know, many, many websites have it. And we should really be very grateful to Moment for that. And then came out Luxon, which is sort of the brainchild of one of the Moment maintainers over a weekend side project, which is sort of the child of Moment, from him learning how he would create that API now that he has all the experience of maintaining Moment. And this is actually now the grandchild of Moment, in that we've learned from that whole process, and this is where we're at right now. And we're hoping that the grandchild generation is actually, with your help, going to be sort of the solution that actually allows us the flexibility and the correctness that we want and need in the future, and to be part of the language rather than just a library. So again, please, please, please go to the proposal, pitch in, your issues are needed. Great. At that case, I'm out of time. I'll leave this up. Please go read the proposal. Thank you very much.